Good morning, my YouTube viewers. Crystal here. I'm just here this morning because I wanted to do a code review. I haven't done a code review in a while because basically I've been really busy working on taking a course on Python, which I didn't get to finish the course because the course locked me out. So I'll have to try to find another course. And then also I was working on practice problems, but I decided I better go ahead and work on this problem because it's only available for a month, and then after a month it'll be taken off the system. So this is a Kaggle problem. Now I have made the link public, so it's shared. And since last night when I wrote the program, I've had 25 views. I haven't had any comments on the views, but I have had 25 views. So I don't know what they thought of it. They haven't told me what they thought of it. And so really what we're going to do is we're going to go through a code review of this program that I wrote last night. And then I'm going to write a blog post on it. And when I write a blog post, I'll give you the link to the Kaggle program. So if you want to see the code on the computer, then what you'll need to do is you'll need to read the blog post, and then you can get the code. Failing that, you can always search me on Kaggle, and then you might find it there. But this is the March 21 tabular exercise. And so basically whenever I ran it up, I had 78.825%. And whenever I got that percentage, obviously it's not great, but it's okay. It means I got somewhere. It means that I made some headway. And I decided that I wasn't going to work on it to try to improve the score. And the reason why is because I'm in the middle of making blog posts. And that's sort of like my bread and butter right now. So I have to carry on making blog posts instead of trying to improve my score on these competitions. But I will say that the competitions can be quite difficult. I would enter more competitions, but I'm not as skilled as I would like to be. But hey ho, we'll just keep on plodding along, and maybe one day we'll be able to properly win a competition. So the first thing we'll do is we'll read the problem statement. So I took the problem statement from the Kaggle site, so I'll just read that. It says, for this competition, you will be predicting a binary target based on a number of feature columns given in the data. All of the feature columns, cat 0 to cat 18, are categorical, and the feature columns cont 0 to cont 10 are continuous. The data set is used for this competition is synthetic, but based on real data set and generated using a CTGAN. The original data set deals with predicting the amount of an insurance claim. Although the features are anonymized, they have properties relating to real-world features. So that's your problem statement. So it's based upon a real-world data set, but the values are anonymized. And I think probably what they did was they just used the same columns. So you don't know what they've done because they just say cat 0 to cat 18 and cont 0 to cont 10. So you don't even know what the columns are all about because they don't tell you what the columns are all about. So now that we've done our problem statement, what we'll do is we'll import the libraries. So these are the libraries that I chose to import in the very beginning because they're the libraries that I'll need to do a lot of the work. So I imported NumPy as MP, I imported Pandas as PD, I imported Matplotlib PyPlot as PLT, and I imported Seaborn as SNS. So I should be able to do work on the mathematics, and I should be able to work on the data frame and the graphics without having to call any libraries up since I'm importing them at the very beginning. And then the next thing we want to do is we want to load our data sets. So since we're loading our data sets, what we're doing is we're going to import the OS, and so that's the operating system in Python. And then so you go into the directory and you look for the file names. And I did study the OS when I was taking that course, but unfortunately they locked me out of the course and they wouldn't, so I wasn't able to complete the course because I got locked out. So that means I will have to find another free Python course that I can take to become more proficient in Python. And then so when we do this more OS and we look for the files to see what files are present, we find out that we have sample submission.csv, train.csv, and test.csv. So we call up train.csv. You can see train.csv, and then the very last column, you got your target. And that's 300,000 rows by 32 columns. And then we call out tests. And then, so you got your tests.csv. Got your column, you got 200,000 rows by 31 columns. So with the train and the test, you've got 500,000 rows, so you've got 500,000 rows. So we check our sample. When our sample, you got your ID and target. And this is misleading because the target says 0.5, but this is actually a binary question. Because it's a binary question, the answer is going to be either 1 or 0. So now what we're going to do is we're going to analyze the target. So what we want to do is we want to use group by to count how many zeros and how many ones you have. So, and then after we use group by to count how many zeros and how many ones we have, we check the percentage. And so we have 74% target at 74% zeros and 1% target. So that indicates that you do have a class imbalance here. It's not a major class imbalance, but it is a class imbalance. So now what we want to do is we make a little graph so you can see what your target is as it is graphically represented. So you've got 76% zeros and 24% ones, and you can see that graphically. Now what we want to do is we want to merge your train and your test. So your target equals train.target. And then what we're going to do is we're going to drop the target. And so drop target axis equals 1, in place equals true, and then test ID equals test.id, train length equals len train, frames equals train and test, combo equals PD concat frames, and then you see combo. So combo, you combine train and test. And so you got 500,000 rows. So I checked that to make sure it was accurate, and it was accurate. And that's interesting, the way that they concat it, because I would like to keep that from future reference. But the way they do it with these monthly competitions is they remove it after you do the monthly competition. So I'll just have to try to memorize this: frames equals train, comma test, combat equal combo equals PD, concat frames, and then combo. Now what we want to do is we want to drop the ID column because you don't need the ID column. So combo.drop ID, axis equals 1, in place equals true. And you can see combo where the ID has been dropped. So now we're going to check for missing values. There are not any missing values in this data set, so that's good. So that means we don't have anything to impute. And now we check our analytics. So we have a heat map, so you can look at the heat map, but you know, if you wanted to, because some people do feature selections, so if you wanted to, you could decide which columns don't really affect the target that much and delete them, but I didn't do that. I just left all the columns in there. And this heat map only deals with the numeric columns. It doesn't deal with the categorical columns. So now we check combo info, so you can see that you've got 19 columns are categorical and 11 columns are numeric. Now what we do is we want to describe it, so we get a description of all the columns. Now what we have to do is we have to ordinal encode the categorical columns. So that's what we've done. We've ordinal encoded all the categorical columns. So now you can see combo. And after we've ordinal encoded them, now what we have to do, because now combo's all numeric, what we have to do is we have to normalize combo. So combo equals combo minus combo.min over combo.max minus combo.min. And then you're going to look at combo. And then when you look at combo, all of the values are going to be a value between 0 and 1. Because that's what happens when you normalize it. You make it a value between 0 and 1. And there's a way you can do standardized as well, but I decided to just make it a value between 0 and 1. But if you wanted to standardize it, you could. Now what we do is we define our x or y equals target, x equals combo, column 0 to train length, and x test equals combo, columns train length to the end. And then so you can see y is going to be either 0 or 1. You can see x is going to be a value between 0 and 1. And you can see x test is going to be a value between 0 and 1. So now we use train test split to split our x for training and validation. We make the test size 1%, we shuffle it, and we give it a random state equals 1. And then we check the shape of all of these new data sets that we have created. Now what we want to do is we want to select our module. And what I had done, I had originally done it on hist gradient boosting classifier, but I only got about a 76% accuracy. And what I wanted to do is I didn't want to spend a lot of time on this competition problem. And the reason why I didn't want to spend a lot of time on it was because, you know, I have to make my blog post and I'll have to do other things. And because of that, I decided, well, I can't do a lot. But just because I'd already created the model, I decided to give logistic regression a try, and I gave logistic regression a try. And what happened when I gave logistic regression a try, I actually got a 78% accuracy when I read it up. So I decided to stick with logistic regression, where C equals 100, class weight equals balance, random state equals 1, max iter equals 10,000, and then you can fit your X train, Y train, and you can print your model. And I decided, well, since I had 2 percentage points better on logistic regression than I did on HIST gradient boosting classifier, I decided I'd stick with that and keep that and not try to improve it anymore. And then so this was the original model that I had used, but it was 2 points less than logistic regression, so I decided not to use it. Predicted on the validation set, I only got an 80% accuracy, or really an 81% accuracy when I predicted on the validation set. I did a confusion matrix, so you can see the confusion matrix. So we did get some wrong on the confusion matrix, and it shows that. So I predicted on the test set, and I prepared the submission. So this is the submission that I prepared. And when I submitted it, I had a 78.825. So that's it for the code review. You can see my answer, and you can use it if you want. It's on Kaggle. If you want to look for it, you can find it on Kaggle. Failing that, you can always read the blog post, and I'll give you the code in the blog post. So if you like my video, please like, subscribe, and share. If you want to be notified whenever I make a video, then please tap on the bell button next to the subscribe button, and you will be notified every time I make a video. So thank you so much for watching my video, and I look forward to making more videos for you in the future.